Welcome to part 3 of the ACE Math Derivatives Review. Today we are going to be working on implicit differentiation. And that's where you have x's and y's that you have to differentiate, okay? So, the first terms are pretty easy. We have to take the derivative of each of these. So first terms are pretty easy. This is 0. This is equal to 3x squared plus 10x to the fourth. But now we have y's. Y. What do we do? Well, basically, when we take the derivative, I already showed you in the last episode that this is the notation. d dx of, x to the fifth. What we can do is rewrite this as d of x to the fifth divided by dx. Basically the derivative of this with respect to x. It doesn't necessarily mean division. There's a lot of technicality involved in there, but this is basically with respect to x. So whenever we take the derivative of y, we're using implicit differentiation, basically to say that we're taking dy dx, right? Derivative of y with respect to x, but then we can use the chain rule and all that, and I'll get into that. But basically that's the general idea. We're taking the derivative with respect to something. So let me just take 5y squared down here. So we're taking d dx of 5y squared. What do? Well, we can treat y as a normal x term, right? And so if we treat y as a normal x term, this becomes 10, and not x, but 10y. But this is where the chain rule comes in. It's like a hidden chain rule, basically, where we treated y as x, but y really is a function of x, so we multiply by dy dx. So it's like the derivative of the inside, because d dx of y is dy dx, right? So that's the derivative of the outside, derivative of the inside, right? So this is just 10y dy dx, or you could even write this as y prime. You don't have to write dy dx, because that can sometimes be a little like a lot to write and kind of weird, but I'm just going to keep it as that, okay? 10y, this becomes just simply 10, but then dy dx plus, okay, now we have the product rule because we have 3x squared and y cubed. So, let me do that down here actually, so let me just bring it down here, plus, open a parentheses, to just, it doesn't need to be there, but I like to group it. So 3x squared, just write it out, times y cubed, derivative of that is going to be 3y squared, so times 3y squared dy dx, plus y cubed. We don't have to write dy dx because it's just writing it out. Only write dy dx when you're actually taking the derivative, times the derivative of 3x squared, which is 6x. No dy dx because that's just normal x, okay? And then plus y to the negative 3 halves power minus 3 halves y to the negative 5 halves power dy dx. A lot of dy dx's, but now I'm just going to remove these parentheses because we don't need them there, okay? So now what we do is we solve for dy dx. Why? Because dy dx just means the derivative of our function, because y is equal to f of x, so the derivative of the entire function with respect to x. So, basically, we factor it out, move it to the other side, or isolate it, and then, yeah. So, okay. So we have 0 is equal to dy dx of, okay, we have so we have this 10y plus this 10 here plus this entire term here, 9x squared y squared, plus, so minus 3 halves y to the negative 5 halves. And that's the end of our dy dx. But then we also have these other terms. We have this plus 3x squared plus 10x to the fourth plus y cubed times 6x plus, I'll write the 6xy cubed like that. And that's it. Okay. Move these to the other side. Let me make this a little easier for me. So let me just get rid of the 0. Removing these, so all these become negative, 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 negative. There, okay? Just moved it to the other side. And then we're going to divide by this entire expression. And so then dy dx is equal to, so let me just write the top here, 10, no wait, no. We write out this here because we're doing this divided by that. So let me kind of just center it here. Negative 3x squared minus 10x to the 4 minus 6xy cubed divided by 10y plus 10 plus 9x squared y squared minus 3 halves x, no, 3 halves y. This is a lot, but you may need to know how to do this. And that's it. That's our derivative. Yes, it's a lot, but the good thing is that it helps you practice. You're probably never going to have an expression this long. It'll probably be like 4 or 5 terms instead of like 150, but this is good practice. So let's move on to the next example. So now we're doing our second and final problem of the episode. Really not that hard, it's just one term, but there is a chain rule and a product rule inside, so yeah. This first side is pretty easy, that's just e to the y, and I'm going to use y prime to familiarize you with that notation as well. And that is equal to sine of this function, so again, you can do a substitution if you want. Doesn't really matter, but I'm just going to do this. So sine of that is going to be cosine of the natural log of xy squared, right, times the derivative of the inside, which is going to give you 1 over xy squared. But we're not done because this is a function inside of this function, which we did a couple in the last episode. So inside of here, this is going to be 1 over xy squared times the derivative of this, which is the product rule. And that's going to give us, so derivative of x is just 1 times, actually, no, I'm not doing it in the right order. I mean, you could do it in any order you want, it doesn't really matter, but just for the sake of ordering, I don't know. So x times 2y, and since we're taking that derivative, that's going to give us a y prime. Again, use dy dx if this makes you think of a y to the first power. If, you know, dy dx is probably the best notation, but it's a lot to write. So I prefer using y prime. And then plus the y squared, do not put y prime at the end because it is not a derivative, it's just the function. Times derivative of x is 1, which is there, okay? Let's see, so yeah, that's actually our only y prime. Yeah, because everything else is like the functions. Oh, okay, we have that y prime too. So let me do this. Let me move this on this side. So we have this 0 is equal to negative e to the y prime plus that. Okay, so I just moved it on that side. This may be a little confusing here. I don't want to cause any confusion, so it's just negative there, right? Okay. So then we have this here, yeah, it's kind of hard to factor this out. Let me just do this so it's easier. So it's easier to just do that. So it's, oh wait, probably should have like thought about what that term was. Oh no, it was just divided by xy squared. Okay, so that's just a huge multiplication there. So I just want to separate that to be able to just add it together, or to, I don't know, it's just easier to separate that way. So we have this 0 is equal to y prime times, let me just group this, negative e to the y plus 2xy divided by xy squared, since we have to do that entire term, plus, yeah, so those are all our y prime terms. We have this cosine ln of xy squared plus y squared over xy squared. Okay. Oops, hold on. No, that's a little too much. Let me close the parentheses there. Okay, so then we just move these over, and I can actually just cancel this y squared and that y squared out. That becomes negative cosine of the natural log of xy squared minus 1 over x is equal to y prime times negative e to the y plus this x and that x cancel, this y and one of these y's cancel, it just becomes 2 over y. So let me just, I'm just going to switch these two sides around, and I'm going to put the y prime here. Okay, y prime is equal to this divided by that, negative cosine natural log xy squared minus 1 over x. Actually, I'll just do x to negative 1 to keep it consistent, divided by negative e to the y plus 2 over y. And you can simplify, cancel a few negatives out, but I'm just going to leave it like that, because that's the end of our derivative. Wow, that's a lot. And yeah, it's probably a little overkill compared to what you're going to do on a test, but it is good to prepare you for the worst. So thanks for watching these 3 parts. The next few will be in a couple weeks, and they'll be about applications of derivatives. So yeah, thank you for watching, and I'll see you in the next episode. Bye.